It's great to be back recording another episode of AI in production. And this time I invited a friend and an ex-collaborator, Omri Levy. We met just over a year and a half ago when you were VP engineering at Round Forest, and we built together a Gen AI system very early on. Omri comes from a very steep background in engineering, almost 15 years in the industry, software engineer, team lead, VP engineering, and now VP R&D at Lumigo, where you've been again hard at work building generative AI applications. We spoke about them at length, and I'm very happy to have you here on the podcast to share with our viewers some of the experience and insights that you've had. Wait, if you'd like to present yourself in a couple of words,
Sure.
we'll kick it off.
Thanks for having me. And definitely, yeah, a year and a half ago we started chatting. It's so interesting how much changed. Like the challenges that we had 2 years ago and the challenges that we are facing today in this area. Wow, it's completely different conversation what we're having today. So yeah, I'm happy to be here. Also happy for the chance that we get to have another chat. Yeah, like you said, I'm today VP R&D at Lumigo. I was at Round Forest before when we first met. Had a few years at Microsoft with a small system known today as Entra. Was also super interesting. Few years abroad, similar web back in the day. Yeah, a lot of data engineering part and really enjoying every different aspect that I had until today.
Great. So let's kick it off. Omri, if you could just tell our viewers a little bit about the system that you've been building, so they can follow along as we deep dive into the different aspects of putting the system in production.
Sure. So, Lumigo today is a monitoring company, monitoring and observability. You know, the bigger players probably as Datadog, New Relic, etc. So what we actually provide is telemetry that the customer is sending us so they can solve production issues, they can debug what's happening, and it's working great. We have a lot of customers, they're sending their data, they're using the UI, and what we started developing about half a year ago is a co-pilot. So if I have an incident in production, it's in the middle of the night, I need to go start opening the graphs, looking where it's coming from, which Lambda function failed, which queue is not functioning. I would have the co-pilot by my side. I can just chat with him with it, and he will tell me, "Yeah, look at this function. It's failing. Look at the database. It started 5 minutes ago." It will help me process and understand what's the root cause, and in the end, it also can offer me a solution or how to remediate and how to mitigate this. So it's just my co-pilot by my side, helping me to troubleshoot the problem using the telemetry that I have on the Lumigo platform.
Yeah. So for people just stepping into Gen AI, so basically a copilot is a chat experience that is context aware, means it has additional information, normally in the environment that you're working on, and it aids you in several different tasks. So as we mentioned, like in your application, basically the user is trying to understand the data, right, or debug some kind of issue, and the copilot is aware of the system and it helps the user navigate, right?
Exactly. It's Copilot, as you said, it's a brand name. It's a variety of those assistants that help you. We know the famous one that also got the name Copilot, which is the coding assistant. But almost every company today, which is building a helper, some sort of a helper function that you can chat and it helps you doing things, call it a Copilot. And ours is like the senior engineer next to you that knows the system, that understands the system, that can really look at the problems and help you navigate to find the root cause analysis and also eventually to solve and get your system back back on.
Great. So you've built this project. It's not your first one. You've successfully reached production. So I guess my first question to you would be, how long did it take you to put the system from POC in production?
I think the first point since we started until we actually met our first beta customers and felt that it's a good enough product to let them try and to get feedback was about 3 months, I think, end to end, since we started designing it till the first implementations until the first features were actually released.
Right. We at Latent have deployed over 20 projects into production and put aside, features which are more of the nature of a POC, like, summarizing or extracting information from a simple body of text. Putting a real system in production after you've rigorously tested it at scale, I've not had anybody say less than 3 months. What is the biggest challenge in moving from a prototype or a POC to production? If you had to name just one.
The biggest challenge I think we had for moving from prototype to production is that we don't know what's going to hit production. You don't know which question is going to come. It's a co-pilot. You can ask them anything. It's using the telemetry of the customer to answer the questions. And there's so many different variables changing when it's going to production. There's different telemetry, different type of context, different amount of data, different use cases. I mean, we have a small production in our company that uses lambdas, etc. The other user might have Kubernetes clusters, hundreds of nodes running. Now, there is really no way to simulate every type of question, every type of environment. So we are actually in a lot of fear about what's going to happen. Is it going to really give good answers? Is it going just to fail when it's going to go to a different environment moving forward? So the biggest challenge for us was to try and simulate as many use cases as possible that we can do, as many types of question and as many types of different sizes of context and telemetry, so we can feel good enough to say, okay, we can give it to a customer and we are pretty much certain that they're going to at least get a good experience. Maybe not the best one, but it's going to be good enough to get feedback.
A couple of follow-up questions. How did you simulate the different use cases? Did you use humans? Did you use synthetic data? Did you log information from customer environments?
Right. So first we did all of them because first we have access. I mean, they're sending the telemetry to us. So we try to play with different types of data. Once, of course, we got consent to use LLM on their data. That was one thing. We actually started and product managers and developers starting logging in and as different customers and trying to use the Copilot to see what's going on. We have built few environments that kind of simulate different types, although they're not real production, just to see how they're going. So if we're based in one technology, we're trying to set up big Kubernetes cluster on the side and another ECS, for example, and another thing on Azure, another thing on Google, so we can start seeing how it works just with the different terminology. See, it doesn't get confused when it's called cloud function, Lambda function, etc., and all of those things. So we were trying to simulate as much as possible, and in this case, once we recorded good transactions, once we recorded good telemetry, we could try and see how it works using evaluation pipelines that we set in the first, just the beginning of the road.
You wanted to get going with an imperfect solution. You were aware that it's not going to work perfectly off the bat. How did you communicate this to customers?
Like you said, not many customers really reached production. Not many co-pilots are really working full time or really made it to production. So once we go to production and we invite our users to use it, we have some sort of this courtesy of this moratorium that it's not going to work very well, maybe, and that's fine because that's AI and LLM. And this type of forgiveness we would have never gotten on any different feature in every different platform that we deployed. When we deployed and we invited them to use the Copilot, and it just gave sometimes very weird answers, they were pretty much okay with it. I mean, it wasn't, what's the thing, we're not going to use it anymore, it's really hectic. Fine, that's what LLMs do. They sometimes do give you wrong things. You need to double check it, you need to work with it. And they were actually very much excited from the number of times that it did work. So the expectation was different. So we didn't really need to prepare them that much. They know they use different copilots, they use Codium, they use different things, and they know it doesn't even work, doesn't always work the best way. And we really took advantage of this state of mind that they have.
Amazing. So You said that you used real world data once getting consent from users, and you also created synthetic data. Can you tell us a bit about the process of creating synthetic data?
Right. So what you need to think about the input. So what actually is the data that we need? Our input is a lot of logs, traces, and some sort of production simulation that we have that we record in this form. So the input that we need to generate is basically what we expect to send to our first agent that gets the the request. So and that's easy for us because basically what we need is logs and traces. That's very easy to get once you get a running environment. So we just set up those environments and recorded data and stored it in S3 buckets as huge JSON files and as used as CSV files. So we can always use and play them again. Once we had those, we can try different types of models, different type of prompts, different type of agents on them. And we didn't really have to change them a lot because they didn't have to be live. It's just fine that they were just sitting there.
You mentioned that you authored different kinds of prompts and different kind of agents. We at Latent like to use LangFuse in order to manage like the different prompts. Did you use a system? Did you build something in-house? How did you treat it? Tell us a
Right.
bit about that.
Today we chose to go with LangChain and we use LangGraph and LangChain, and also the pipelines go over LangSmith, so we use it to debug and to see what's going on. For us, it's an amazing ecosystem that works very well to all of the use cases. We cater all of the use cases, including the embedding use cases that we having and the graph Frag that we are building. So it's just one-stop shop. We use the agents and the tools mechanism built inside the LangChain. We started with the chains with the with the prompts, and basically everything we're doing is inside this ecosystem. And a good addition is LangGraph that we heavily utilize to create all those more complex agents talking to agents, conditional nodes, etc. It's an amazing framework for us. We never felt anything missing. Also, a great value that we get from using that is that we tried so many different models. So I think until today we tried Anthropic models, we tried Bedrock, AWS models, Gemini, and also OpenAI. So we can switch and see which one is working for us once we were able to build this abstract
And
layer.
so that's one of the great things that LangChain really gives you as a ecosystem. It's really easy to just replace the underlying model. And with Langsmith, it's really easy to test things. And why did you test so many different models?
I think that's the beauty about the time that we are living in. I joined a roundtable of VPs and founders and etc. of one of the big founding of a big investment fund, and one of the people said, "Look, I'm frightened. I don't know which model to choose. I don't know which way to go because tomorrow there will be a new model that's going to give me different advantages," and that was actually frightening because he knew that he needs this flexibility to try different models. And we wanted this flexibility to try different models because each one, today, for example, we see the new one that has reasoning. So, of course, we want to take advantage of that. And for example, Gemini, the Flash one was really, really fast with a huge context. So we want to try because we encountered different problems at each time of the development. One time it wasn't fast enough. One time it wasn't smart enough. And another time we need a bigger context window because we send tons of logs and traces and some big production flows. So we were trying to balance between the different needs that we had. And sometimes one model gave us good reasoning and the other one has a huge context one. And the other one was just really, really fast and cheap. So it could cater a lot of tools calling and a lot of simple summarization. Actions. So we didn't want to be forced to try and hack the prompt or hack the model so it will fix one thing. We want always to move forward. And we know that in 2 months from today, we're going to try a different one because it's going to be better, it's going to be cheaper, it's going to be faster. So why not try this one?
Amazing. You mentioned so many things that I want to touch on. The first is GraphRag. You threw that out. Uh, First of all, we've used GraphRag. I think it's amazing. The reason being, at the end of the day, many of the systems that we build using LLMs rely heavily on RAG, and to some extent, it's an indexing problem. RAG is never just a silver bullet. It's not that you take the information, you vectorize it, and it's now ready. You have to think how you'll be retrieving the information. What is the kind of questions that you're trying to answer or flow that you're trying to serve. In the old days, basically you could index, by keyword, title, and now we have this whole new world of semantic meaning. But many a times, indexing things semantically does not accurately capture all of the relationships. So we found that out first time. I think it was almost a year ago. We built a system for a large a government office, and they their information was very multimodality. It had different types of files from transcriptions, videos, textual data, uh, and in that data there were a lot of people reoccurring in different places. So you wanted to capture both the semantical meaning of the documents and be able to ask about, like, what is happening here in the context. But we also wanted to be able to jump around between different documents, which may not describe the same situation, but they would still have that connecting point of, let's say, having the same person. And if
Right.
if two scripts or books have the mention of the same name, if you're gonna just semantically embed the entire book, the name is just a small detail. But if you extract it and you put it in a graph, you now have both the semantic meaning and the graph, and you're able to traverse information in those two dimensions. And it, in certain cases, it adds a tremendous amount of value.
It's actually a very powerful tool, but then you actually encounter the first issue, which is, like you said, it's semantics. So actually, what you're taking and what you're trying to build a vector from, and understanding this process of transferring a vector or a data or a piece of code or a document into a vector and what's actually happening there. What I really need to make sure is that when I'm creating the query, and when I turn this into a vector, there is some sort of a connection between the vector just indexed and the vector that just created. And that's actually, so you always need to think about not what you're doing now, not about the offline processing of preparing the data, about the query that's coming in, what this query is going to have, which names or which information or which kind of context it's going to have, because that needs to match then the vectors. Otherwise, the search doesn't mean anything.
And this brings me to another point. Uh, we've learned over the time, and I think back when you were at Round Forest, it was the first time that we realized how important it was to have good benchmarks from the get-go, because we're trying to do exactly what you said. If we simplify all of the RAG, like all of the LLM application problems to a RAG problem, which we sort of can for this conversation, at the end of the day, we're trying to do exactly what you said. We were getting a query input from the user, and we have to match it to the closest query that we've already vectorized. Eh, And the more examples that we have, the better the benchmark is going to be, the better we're going to be able to train the system at the end of the day.
Exactly. Sometimes there's really more than just one answer. So but then it tries this to like roll this problem to the LLM, but there's really no reason why the LLM would know how to answer something that in real life can have also two or three right answers. And we have this issue also today when we index code, and then the user has a problem in some database call, but there are five different layers of calling to a database in normal code base, right? There is the calling function, and there is the service, and there is the abstraction, there is the model, and there is the actual package that's being used to call to the database. So now you need to say the customer has a problem, something went wrong with the database. They're asking, ask me to find the root cause for that. And then what do we want the LLM actually to point? The data access layer or the calling function or really the bad query that happened in the closed level, etc. And so so this is one thing you really need to make sure that you understand and you also allow, and then you also evaluate the way in that sense. So even if we got the wrong answer, look twice. Is it really the wrong answer? Or we just need to think again about what is the right answer? And the second thing, as you mentioned, is about sometimes you cannot get all the context you need just from the one simple reg query and get the 10 best vectors and try to find. Sometimes you really need to use different type of relationships to enrich the data that you have, and therefore you really need to build some sort of a graph reg. Otherwise, you're just going to keep hitting, and you're going to try different contexts, different type of formulation, different type of embedding models, but you're just not going to get anywhere. Because again, what you need is not in the semantics, like you said. You need what's missing. What's missing now to get the right context, to get the right answer, is not in the semantics, in a different type of relationship that maybe cannot be reduced to another line in the context you want to create a vector from. And that's classic code, by the way. There are different type of connection between functions, between callings, between packages. So we try to build those connections in the graph, and the kind of semantic what the code is doing, this is what we're trying to create a vector from.
Did you use a Microsoft's GraphRag or some other package?
So it was very tempting. But by the way, today Microsoft is the almost the only one. I saw another one, open source project called, I think, LightRag, which seems to be getting more and more and more users. But no, and this is another thing, like we were thinking, there are so many problems, by the way, of this type, that we're trying to think what is the best tool. So we have a graph and we have vectors, for example. And then do we really need AI graph database? No, because this solution, we have graph databases where before we know how to build graphs. Our half of the system is transaction based, so we have graphs building there. We had this some sort of dilemma, by the way, also with offline processing. So we were trying to take big repo and break it into code blocks, and then try each one of them to do summarization and embedding and some sort of different operations, and then store it in a database. And then there are many problems when you do it with LLM, because first, of course, the quality, and then it's very flaky. Sometimes the endpoint doesn't work. Sometimes AWS is deciding to be really, really slow, or Google is not really giving you what you need. So we start hacking the prompt, changing the summarization, thinking about maybe changing to a different model database. But once we zoomed out, we actually, let's take the word AI out of this problem. We are left with offline processing problem. Now this is already a solved problem with so many different solutions. So we just picked one. The same with the graph. We didn't feel that we need some sort of a graph reg solution, although it's probably better. But we know how to build graphs, and we know how to search within graphs, and we know how to get to different nodes. So we're just using what we have. And that's what we have today. We don't have anything special. We are not based on Azure for the moment. Sometimes just zoom out, take out the AI out of the problem, and see that you actually have good solutions lying around somewhere.
So you mentioned Azure, and we've spoken about the application layer in LLMs. I want to take you down to the infrastructure layer. So what infrastructure did you choose?
So we are a serverless company. Our product is aiming towards serverless customers. At least at the beginning today, we have more offerings, but a lot of our system is based on Lambda functions. So we choose that to be the operating system for everything that's going the infrastructure. We use queues, we use step functions, we use Lambda function as is. We use databases. DynamoDB is a big thing we are going to use, and we use different type of databases inside the system. So that's the underlying layer. And for the cloud, we are based on AWS, so we use Bedrock. We are now experimenting with Gemini. We tried a little OpenAI at a certain point moving forward, but that's what's very easy to change, just the model that we are using. But it's not that easy to change models once you're running in production, because you're depending on so many different things that's going to happen as you wanted. The semantics that you're using, the structure, the chain of thought that you actually did, and of course retrieving the data and returning the right formats that you expect to get in your backend. So it takes a lot of experimentation, and many times also a little bit of adoption that we need to do in the code in order to make sure it performs well also with a better model.
That's an amazing tip. Despite that it might be easy to replace the model that you're accessing, let's say you're using LangChain, or you built a really modular architecture and you're just able to replace the API call, a lot of things will be affected. And some small things like just, extraction of information or handling of JSON, as you mentioned, uh, you're not necessarily going to be testing for all of those things. So you have to really tread lightly. Taking you back to the infrastructure, what are some bottlenecks that you experience there, if you experience bottlenecks on the infrastructure layer, and how do you
Right.
solve them?
So the main challenge that we have by far is the flakiness of the models. Each and every one that we tried does not guarantee that it's going to return an answer fast, that it's going to give you in a timely manner what you need, and that was mainly the problem. Sometimes even if it works well, it takes 10 to 15 seconds to get an answer. But we also saw huge differences in our production environment using Bedrock and also using Gemini, that the P95 can be 50, 60, and sometimes even 100 seconds. P95 of the same response that usually comes back in 10 to 15 seconds. And this is a big pain because it's not P99.99, it's P95, and meaning that 5%. And let's say that I'm having a conversation with a co-pilot, I have at least 20 exchanges, it's very common. It means that almost every customer statistically is going to experience something bad happening during their conversation, they work with a co-pilot. So there are different types. Of course, it's not just us experiencing that. There are two things that we did to tackle that. One is to try and send two requests in the critical paths and waiting on the first ones coming back, trying to mitigate, but it was a bit costly, but for the critical paths, we did it. And the second one that we just tried because it's being rolled out one cloud after the other, it's called provision throughput, and it's giving you some sort of a dedicated resources for you to use. You're not depending only on the shared and common resources. It's kind of a balance between bringing your own GPU and using just cloud. So we're trying this now, and it's actually providing good solutions to this problem.
Just to translate what you said or reiterate, you're basically saying that every customer is liable to hit a 2-minute delay in an answer. Most of the time, they're going to get 15, 16, 20-second answers, which are good and they're probably used to. But the nature of the beast is that every 20 or so on average, they're going to get a 2-minute answer.
Right.
Uh,
And
what
this is a
happens?
timeout, by the way. So it's not just their first are not going to wait for 2 minutes, and second, it's probably going to end up in a timeout in the front end. So it's going to look really not good.
So I love your solution for like handling the critical paths differently. And I'll just add to that we a lot of the times, we do waterfalls. Not to solve the P95s. That's not going to solve it. But sometimes there are issues with certain models. Once we identify it, we always have a fallback to make sure that the systems can always run as smooth as possible.
Right.
Um, Moving on from the infrastructure, we mentioned early on that these systems are not 100%, and there's always hallucinations or incorrect responses. You already mentioned the first thing, which is aligning with the users. When you release it, you specifically tagged it as beta. I'm sure you also communicated to the customers. Uh, what are some other things that you did in order to prevent hallucinations or incorrect responses?
Right. So, hallucination, we didn't really experience that much. I mean, some sort of weird answers, making up data that wasn't there, saying that it happened in a type of database that didn't exist. Those kind of things almost never happen. What did happen a lot is, of course, wrong answers. And that's basically from the nature of what we're doing. I mean, if you take an engineer today, put them to to debug a production problem, they're also going to give you sometimes wrong. Say it happened because of the database, but it didn't really happen because of the database. It happened because of some API, something like that. So we need to really work on that, and that we did with like really good debugging. So if it gave a wrong answer, we need to track down the thinking process of what actually happened, and that's basically what we did with every wrong answer. We tagged. The users can also tag, thumbs up, thumb down. But we looked at it and then we tried to look at the logs and see what was the thinking process. So it actually yields the entire chain of thought that happened throughout the process, both in evaluation pipelines, but also in production. And then we were trying to understand what was missing. Usually it's one of the two: missing data For example, if the problem is in some sort of an API, but we did not provide this information within the context. And because we have to make sure, we have to make decisions about how we're going to shrink down the context. We cannot give everything that we have, all the logs and all the endpoints and all the APIs and all the traces to the context, because it's either it's going to be big enough or it's going to be very much confusing. So this was either one of those missing data, or what was even more common is sometimes unclear data. Because when you build a database and when you have your own stack trace and when you have your own team, you give names to things. For example, in the database in our system, there was some sort of a field called logs only. It had completely different meaning than what you would have guessed that it means, but everyone in the team knew it. But of course, the LLM didn't know it. So they looked at those kind of weird fields that were coming or weird names that only mean something to us. And then we could have really inference, understand that the LLM was giving wrong answers because they did not understand what those fields and what the data actually meant, because it's kind of based on internal conventions. So once we were able to look at the thinking process, it's really easy to pinpoint the problem and saying, why did it think that way? Because it completely didn't understand what this field is meaning.
Amazing. A few things I want to touch on there. Like, first of all, you said something which I can really relate to. An engineer also is going to get it wrong some of the times. We worked on a couple of opportunities of text to SQL, which I'm sure you're familiar with. They add a tremendous amount of value. Uh, and one of the first things we always do is we communicate to the customer that even an analyst, on average, in the benchmark, gets the query right 94% of the time. That's a very important alignment point. Like, I wouldn't expect us to be better than 94 unless we really descope it, and even so, it's still not going to be 100. The other thing that you said, which I loved, and we try to do it when possible, but obviously we don't control the application layer or the product. We were normally focusing on the AI, is the thumbs up, thumbs down. Great way to collect feedback, have data automatically tagged, especially if you're building a chat application or a copilot, which is an entire conversation up to a certain point. If at a certain point you just get that thumbs up, it's priceless for what it offers in value for further training of the system.
Priceless is the right word. It's so simple to implement and it gives so much value.
It took 3 months, but you've been developing it for much longer. And I know that you were very much in an environment that the requirements were continuously changing. So my first question is, why were they changing? And my second question is, how do you handle those changes along the way?
Why is it changing? First, because it's very difficult to define definition of done. For example, how would like the PM define what they want to do? They present them some sort of a slide with a question, pinpoint me or tell me, help me to solve this problem. And then there is a solution. Now, there could be so many things lying beneath there. For example, we solved it only for a case in which you have the stack trace to begin with. But then come the API, and then they trying to do it with just a random question, and didn't really work that well because there are so many different use cases and so many different variations of what you can do, because it's free text, it's Copilot, that it was very, very, very difficult to define what they actually want to achieve. And once you solve it for one use case, you didn't necessarily solve it for all use cases. So that's one thing that was a lot of misalignment throughout the way in which we presented the solution, and then the product says, yeah, but I want to solve also different things that were kind of implied but weren't really clear in the definition of done, retrieving some sort of data. It's happened almost in every aspect. And the other thing was about really getting back the feedback from the customers. So it was changing a lot. And first we thought that the main game changer is going to be the code, by the way. But then we saw that they actually loved the normal Copilot and just the ones everywhere in the product. So once we got the feedback, all the time, every week, every other day, there is a conversation with the customer, to be honest. There are a lot of conversations with the customer.
What did you
And
do with that feedback specifically?
with the feedback from the customers about the Copilot.
I assume you put it in some kind of benchmark.
What we do with the feedback is two things. First, we try to see what was working well, what was not working well, right? Because we don't really know how the world is behaving completely. We want to understand and get the sense of what we deployed, which kind of problems does it solve. And the other thing that we are getting is what actually matters to them. And it's very surprising because, like we said, we thought we're going to release a very big of set of features at the beginning, and that was the minimum. And then after 3 months, we said, well, let's not wait, let's start going on. We were surprised to hear how much the small subset of things that we actually released was valuable. We're really surprised. We didn't think it's going to be that big. So that's why we rolled it out, because we thought, well, they're super enjoying what we're giving. So we're trying to understand what's the pain, what they really like, and which type of problems are we actually good in solving. And that's, like you said, that's creating the next benchmark of what we have to do. But I have to say, also in this case, be very, very agile and be also with constant feedback from the customers. And that's why, by the way, we weren't afraid of burning customers, because even one or two is not going to like it. The value that we're going to get from their feedback is going to be priceless and going to be worth everything.
That is an amazing point, that feedback is priceless. And the fact that you put such an emphasis on incorporating it and understanding that it's actually part of your engine for improving the system is phenomenal. We're nearing the end. So what is the business impact that the AI system had so far?
That's a good question, Jonathan, because like I told you in a previous conversation, we didn't start it for the business impact per se. And by the way, it was also surprising because the first feedback that we got from the customers, we actually liked the UI so much. We liked Lumigo. That's why we use it. We get used to the UI and the UX, so we don't need a co-pilot. Now, I bet we're not the only ones who experience this kind of feedback, because we emphasize UI, of course, a lot, and we put a lot of effort in making all of our products very, very comfortable for the users, and they get used to it. So now they say, why should I go to this Copilot and start using it? I just love the way you made things, and I just love the pages.
The
Um,
experience.
yeah, they love the experience. We made it tailor made to work, and they actually appreciate it. So it's not like today someone is coming to the product because of so someone we thought someone's going to come to the product because of the AI, but today we have paying customers for these solutions, by the way, for the Copilot. So today, after a few months after we rolled out, there are users who are saying there is a huge impact in the time to solve an issue for me, and it's really helpful for the different type of developers that are not familiar with the entire system. So once we were moving, we were able to cover another piece of needs, let's say, that we didn't think that we're going to cover before, that we didn't aim to. And this catering to more younger, for example, less experienced, or to big system in which you're taking a shift but you don't really know what's going on, and solving time faster.
Can you share maybe statistics on how much faster issues are being resolved if a user is using the Copilot?
So that's a great question. We don't have the benchmark yet. We just have feedback. So we have testimonials saying, we have recordings, we have feedback. We have our own number that we are aiming to, but we are not yet in really being able to say how much faster. We just know that for some very big customers, they felt that it's big enough and makes a lot of difference. So they're willing to pay good money for the Copilot.
Yeah, that's amazing. So we're wrapping up, and I'll finish up with two like rapid fire questions. The first one is, which AI tool you can't live without, and you can't say the Copilot of Lumigo?
Yeah, damn, I need to think again. I just love. Actually, it's gonna be very simple. I think that the entire ecosystem of coding tools is amazing. I use Copilot, but I use Codium. I just try Claude Code, by the way, just now to see how it's working this week, and start. And I use Cursor. I have all of them open, and I still deciding which one is better, and they keep like in a big race of arm race to see which one is getting ahead of the other one. But I can't imagine coding today without any one of those tools.
We're addicted to Cursor.
Yeah,
We have this like internal sheet of tips and tricks that we share across the company. We're also a hybrid company, and we have remote offices in two locations. Uh, and it's been phenomenal, the adoption of Cursor and what
amazing.
it's done.
It's really a wonder.
Yeah. My next question is, where do you see AI in the next couple of years? How do you see it evolving?
Right. So I think what's happening today with AI is actually, like was stated from Jared from Microsoft, it's transferring from technology to commodity. It's not that much of a groundbreaking technology that we are amazed by. It's something that every other research lab in a university is developing another type of it. There's so many coming now. So what's going to happen in the next few years? It's like every commodity, like TV, computer, etc. They're going to start to have proving themselves not as wow, what is an amazing technology, but what impact do they make on our lives? And I expect two things to happen. First, it's going to be much easier to do that. So, for example, if you work kind of hard to take the APIs and to take the infrastructure from Gemini or from OpenAI, from Claude, to make it work for our use case, for our customers, for to fine tune it, to build a RAG, etc. It's going to be much easier to do it. I think it's going to be just plug and play. It's going to make to be very obvious that those tools were not just made for you to adapt to them, but them to really easily adapt to your use case, to build slides, to solve things, to do everything. And then within a few years, I expect to see just everything happening with AI. So it's going to be the go-to solution for everything that we're going to use. And it's going to be very obvious that that's what we're going to do. Because it's going to be super cheap and super fast and super easy to use. So what we're experiencing today, I think it's just the tip of the ice. I expect to be almost like for free to use this infrastructure of AI within the upcoming few years.
Well, Omri, I'd like to thank you for joining us. We covered a lot from synthetic data to how to manage different agents and prompts, and spoke about graph rags and some aspects not only on the LLM application but also on the product level, such as collecting feedback and using the thumbs up and thumbs down approach. To the rest of our viewers, I'd like to thank you for joining, and we'll see you again next week. Bye.
Thank you, Nathan. It was great. See ya.